Hello, folks. Welcome to Steve's Place. It's Sunday, 6 p.m. on January 11th of a new year. And we're looking forward to um, the future. Tonight we have a very interesting guest, Mr. Hakasays. I'll get more to that in a minute. Meantime, I want to remind everyone we still have the uh, our 24 and 25 videos available. Just go to our website and look for the logo or give me a call if you can't find it. I need to double check. I also got the next year's conference set up on the web now. So if you just go up to our website at teslatech.info, and you can register for the conference. Right now we're offering 50% off. Um, so that'll be till January 15th, which is like Friday, I think. So get signed up for that as soon as you can. After that, it drops down to, uh, I believe, 45% after that. And if you want to save an extra 5%, give me a call. And if you can, and Zelle the money, if you use Zelle, I can give you an extra 5% discount because on Zelle, I don't have to, I don't get charged 5% from the credit cards. So I'll give it to you guys. And so just give me a call on that, 520-252-0374. It's going to be, I can just feel it's going to be a great year. And then, most important of all, I need people to get signed up for YouTube. If you're not on YouTube, I would hope that you would consider it. You should be at least a subscriber because subscriptions are free, And I'd like to hit about 30,000 subscribers before the conference, And so we're going to be starting to do a big push up there. Now that I am moved, and I can start off, unpacking stuff, we're going to be at the point where pretty soon I will be able to work on stuff again. And I have all these videos where I have about 100 videos from past conferences in the 80s and 90s we could put up on there, and that's what we'll be doing next. I encourage everyone to become a member. It's $9.99 a month. Just go to the yellow box here and click on Tesla channel. That will take you to the channel. We also have a conference and speaker directory on there where you can click on it, and it will take you to their list. Like we have conference lists of all these are our conferences and that. And so anyway, it's like $9.99 a month. I encourage everyone to sign up and join. That's in addition to subscriptions. Subscribers will get you a free, we have free ones, but it will also notify when we put something up there. Membership, we have a lot of membership only videos up there, and you have to be a member to see those. And we'll be putting all the 24 and 25 ones up there eventually here. It's just we've been so backed up because we moved. And for those of you who haven't heard, I live in the middle of nowhere. It takes me 40 minutes to get to anywhere. Whether I'm going to Laughlin or where I'm going to Las Vegas, it's 40 minutes. So any trip to the store is a 3-hour ordeal. So anyway, but I love it out here. It's great. I have a huge place to work out of finally, and everything's going to be working okay. Now, tonight's speaker is Mr. Hakasays. I got a little bit of information about him. Okay, he's involved in fringe science for decades. His products span an array of fields, come from electronics to computers to 3D printing, steam turbines, woodwork, and machining. A regular Tesla kind of guy. And a Robert Heinlein and MacGyver fan. His motto is specialization is for insects. So he also is working on the lines of work that Eric Dollard and EPD Labs are working on. And so anyway, and he's even doing stuff with Philo Farnsworth material. And Farnsworth was working on fusion at the end and felt that he couldn't provide a means to get the stars. So without further ado, Here is Hakasays. Good to have you here, Mr.
Wow.
Hackett. So,
Thank you, Steve. Thank you for having me. So,
and we're looking forward to coming to the conference. I presume you're going to take and bring a bunch of equipment with you, huh?
we'll see what I
Maybe.
can pack on the plane. It's always a question of how much can you pack into a couple packs of luggage and still be worth playing. Um, yeah, it'll be fun regardless. I got to have something to show and tell.
Yeah, and consider driving because we have free parking. A big thing for anyone who's ever been to LA and that, you have to pay for parking there, or even in Vegas they make you pay now. But we have free parking in Albuquerque.
Let me look at that. Southern California might be a bit of a drive, but if I got to carry, more than 500 pounds of equipment, that might be the only way to do it.
Well, it takes me about 9 hours from Vegas, so
Uh,
probably about the same difference. But
oh well, such is life.
it's a pleasant drive. It's all 4 lanes all the way, and they also have a train. Amtrak goes through there, and Greyhound goes through there. Thank God, and Greyhound she's going. And like I say, and there's two interstate highways, one going north and south, and one's going east and west. So Albuquerque is like a crossroads, and it's an easy place to get to. We have reasonable hotel rates, this year, you know, and lots of food and lots of good people. And that's one thing about our conference. You're gonna love meeting the people.
That was always what got me that I didn't know about the conferences when I first started going to them. Was I always assumed it was the presenters and that was the foreground. But when you start going there, you realize the networking and the stuff that goes on behind the scenes is probably 80% of what goes on. You can get behind the scenes and buy someone a beer and have talk and get what they actually have, get their actual opinions. And yeah, the atmosphere is always so interesting. You get the random tinkerer, you get an engineer, you get a PhD physicist all at the same table eating dinner, discussing the nature of reality.
Yeah. Anyway, so what do you have for us tonight?
So, yeah, thanks for having me. So before we start, anyone with questions and comments, feel free to ask in the doobly doo, and I'll try to get them either along the way or at the end. For those that don't know me, I go by Hakasays, a longtime researcher, experimenter in the fringe sciences. I grew up back in the day when you were supposed to keep your internet and personal life separate. So Hakasays will be what I go by. It's actually a bilingual play on words, Japanese word for Hakasei, professor, scientist, teacher, says English word for speak. So combined, Hakasays is professor speaks, which I kind of find appropriate. Uh, what brought me here? So for the longest time, I was sort of uh, a tinker experimenter, like a lot of you, where you would replicate, build a Bedini motor, build something by photos or rough schematics, and then you put it together and you find out that it spins or it does something, but it doesn't do what you want it to. And I think what kept me hindered a lot of the time was I wasn't building based on principles. I was building based on stories. I was building based on schematics. I wasn't building based on certain parameters. What got me onto the right road was I started following certain people that gave more precise answers, engineering answers, and more specifically, when they gave a design or a schematic or a blueprint, even if it was math I didn't understand, is they would give a schematic, something, and I would go home and build it, and lo and behold, it did exactly what they said it would. So what I'm talking about today is sort of a foundation on what came from some discussions from Eric Dollard and others is Tesla's Xtra coils. Uh, I'm assuming that pretty much everybody here watching this video has seen a Tesla coil probably in life. They've seen all the sparks and the lightning that they produced. They're probably used to seeing specific type of coil where it's a nice thin long red magnet wire filled coil and it makes these nice sharp jagged sparks on them. But I don't think anybody's noticed that a lot of these coils that people are building today don't look a lot like the coils that Tesla was actually building in his day. And that's sort of what got me back onto this track of going back to the basics, simpler and more precise, to try to understand where Tesla was coming from and build a foundation from there that we can actually understand and operate from. So everybody here has probably seen a Tesla coil. Has anybody? How many people here have probably built one? Several, I'm guessing. Maybe not everybody, but probably more than 5 or 10. How many people here watching this have built a Tesla coil following Tesla's actual notes, following his designs, and building a Tesla coil that looked like something Tesla had actually built? Very, very rare. If you look at the, if we go to the actual slides here. So if you look at the picture in this, and I'm sure everybody who's seen this archetypical picture from Tesla, is the coil in the middle of the room is an extra coil. The primary and the secondary are actually on the corners of the room. You can barely see them with some vertical posts, but they're almost not visible. Notice that the extra coil is almost a 1-to-1 ratio, and notice that you don't see these types of Tesla coils being built today. I don't know. I have any people probably haven't seen a lot of coils that resemble this. So if we go to the basics, Wikipedia says that a Tesla coil is a resonant transformer invented by Tesla, produces high voltage, low current, high frequency alternating current electricity. Tesla experimented with a number of different configurations consisting of 2 or sometimes 3 coupled resonant electric circuits. How many Tesla coils have you seen in practice today that have employed 3 coils? Have you seen primary? You've seen secondary, but have you seen any coils that used an extra? Does anybody here know what an extra coil actually is and what its function is? We look at the picture here. All of the sparks that are being thrown off this coil, those are coming off of the extra coil. The primary and the secondary coil in the very, very back of the room, you can almost not see them, is the actual primary and secondary. This doesn't look like a coil that you see today. We look at some of these other pictures. You can see that long ring, a horizontal ring that circles the room. That is actually the primary and the secondary. Extra coil is on the right side where the lightning's coming from. So have you seen anybody building Tesla coils that have a very, very wide diameter primary with a secondary that's only a few dozen turns, and an extra coil that has only maybe 100 turns? We look at the slide. Compare these two. Do these look any alike? The people that are building Tesla coils today, are they building Tesla coils that look like Tesla's coils? Can we call them Tesla coils if they don't look anything like Tesla? If we go back in time, we find out that a lot of the coils that we call Tesla coils today are potentially not Tesla coils at all, but they're from a person named Marie Odin in the 1890s had developed a resonant high frequency, high voltage oscillating transformer. And if you compare the schematics, you'll find that the most Tesla coils today are actually technically Odin coils. They are not Tesla coils because they do not have a Tesla coil. They do not have an extra coil. We pass forward. We see this is a coil that is a Tesla coil, that can be considered a Tesla coil. On the very top, we have our old photo from Tesla and the diagrams and schematics that went with it. On the bottom, we have a presentation that was from Eric Dollard in the 2019 ESTC conference. This extra coil consisted of a 3-turn primary, a 15 to 20 turn secondary on the long side on the ring, and in the very middle was an extra coil. The extra coil was where most of the magic happened. This resonant coil was designed as a 1/20th Colorado Springs coil as part of a research project, an experiment to try to see what Tesla was actually building in Colorado Springs, understand the tuning, the construction, and the design practices, and how the performance actually differed from the coils that most people built. So seeing the difference between that led me onto this road of experimenting with Tesla coils to understand the difference between what was being built back then and what's being built today. So if we compare a modern Tesla coil, we'll call it modern coil, is the coils that we see today are very tall. They have a very long, thin frame. The modern coils usually have 1,000 turns or more. The coil that we saw in Tesla's photos was less than 100 or less than 150. The coils that are wound today are very thin wire. They have a high resistance and they're wound with thousands of turns. The coil we see in Tesla's photos and the replica we see in 2019 was designed specifically for low resistance, higher efficiency. Coils today are very high inductance, and capacitance is either minimized or ignored entirely. Coils in Tesla's day were balanced. They had a high amount of inductance and a high amount of capacitance. As a result, the coils today, coils today tend to have a lower Q factor or quality factor. Fancy quality factor is essentially a term for how well it rings, how much it resonates. If you would strike a bell that has a low Q factor, then it will have a very dull thud. If it has a high Q factor, it will ring continuously for a longer period of time. As a side effect, the Tesla coils today tend to be very wide band. They operate over a long frequency, and they're less efficient. The Tesla coils in the day that use Xtra coils were much more narrow band and higher efficiency. As a result of some other factors, the coils that are made today tend to be very stable with a very predictable frequency. Once you wind a single coil, thought I brought one with. There's very little difference depending on where you put it in the middle of a coil or side of a room or whatever. But a Tesla coil, an Xtra coil that you wind following Tesla's notes is much more harder to tune because it's so much higher efficiency. It turns out the coils are so efficient that any objects and bodies within the room will begin to affect the tuning and the frequency, which has a very significant impact. If we look at the efficiency and performance, this was I had done this right as I was working on the presentation. Actually, was this Electro Boom had made a Tesla coil some years back before my presentation, and he made a Tesla coil. You'll see has a nice long solenoid with a lot of hundreds of turns. It has a very simple primary, and you can just barely note from the power supply that he's putting in 20 volts at 1 amp. So this is 20 watts, and he is lighting up a tiny compact fluorescent bulb at 3-4 inches away. I'll show you in a little bit that if you wind a Tesla coil specifically an Xtra coil with the proper principles, you can have much higher efficiencies that will vastly surpass what you see in systems like this. And actually, I'll go back. I will might as well do a demonstration here and explain what we have. If you want to minimize the slide real quick. It disappeared. Okay. So the coils that you've seen to this point are Tesla coils that have a primary, and Tesla coils that have a secondary. There's a primary where the energy circulates. There's a secondary where the energy is amplified. Very few people that I'm aware of know that you can have a Tesla coil that is just one coil. It's just an Xtra. Very few people seem to know that this by itself is a transformer. This is a primary, this is a secondary, this is an Xtra coil, all in one piece with one wire. And what you can do is, instead of having the primary and the secondary, the Xtra coil by itself is a resonant transformer that takes high current, low voltage on one side and outputs very high voltage, low current on the other side. And it does it at a very specific resonant frequency. Now, you can probably see here, this is an open frame material. This has high density. This is actually 3D printed, made from PLA. But you'll notice that there's very minimal framing material. I didn't wind this on a tube or anything. And I wound this with some amount of spacing between the leads. There's a very specific reason for this, is the spacing between the wires allows certain amounts of energy, both magnetic and dielectric coupling, to build up in free space. And what happens is when you have a coil like this, it takes a very small amount of power pumping energy into one side to get an extremely high translation of potential on the other side with just this one coil. So the demonstration that I have here, which you should be able to see. So what I have here is I have an Xtra coil. This is one coil. There's no primary, there's no secondary. This is just one single coil wound on high density polyethylene, very low dielectric loss frame. The people that can't see it, we'll have some better quality photos afterwards. That should be able to clean up. But anyway, so this is one coil. It's about 100 turns of 20 gauge magnet wire. It has no primary. It has no secondary. It's just a single coil. Below this, I have a frequency generator. This is a common function generator, DDS signal generator. You'll find that I've tested a multitude of these. They all seem to have pretty much the same characteristics, where they output up to about 20 volts, 50 ohms. And when you test the power, these do not put out, anybody that's used these knows they put out almost no power at all. It turns out it's about between a quarter and a third of a watt. So if you remember the slide from a moment ago, Electro Boom had made a Tesla coil that was 20 watts, and he was lighting a little fluorescent tube at a couple inches away. This is simpler. All I have, this is a signal generator with one lead. You can't really see it very well. We'll look at other diagrams or previous demonstrations that I've had. I think I have some older videos on YouTube. But the signal generator primary, the signal generator positive, is leading to the lower end, the lower lead on this coil. The upper end of this coil is not connected to anything. There is just a bare piece of magnet wire sticking out of the top. So technically, there's no circuit here. It's a SIR. There's a positive lead. There is one wire going to the bottom of this coil, and there's no wire on the top. People don't realize that this is a Tesla coil. This is actually a very powerful, a very effective Tesla coil, because it turns out, despite being less than 1 watt of power, that this is able to translate 20 volts on the low end to thousands and thousands of volts on the high end. The reason it can do that is because it's designed for peak efficiency. There is a specific amount of spacing between the turns. There's a specific geometry. It has a certain height to width ratio that is very close to 1. It has relatively thick wire, and it has extremely low loss framing material. This is made from polyethylene, which has one of the lowest dielectric loss tangents that is available. Now, when this coil is energized, we pump energy into the coil. This acts as a transformer by itself. Energy circulates back and forth inside the magnetic and dielectric fields. Magnetic field everybody knows about because they know what a solenoid and a coil is, but they don't realize there is also a dielectric component. Every turn between every layer of this is a turn in a capacitor. There's capacitance. There's a little capacitance between each one of these turns. And that capacitance between everything extends far off into space, several feet or several tens of feet. That's detectable at a long distance. So what happens is this Tesla coil that has no primary and no secondary, that's outputting roughly usually when you test this, it comes out to between 0.25 and 0.33 watts. So you can say it's between a quarter and a third of a watt. And when we have this tuned right, if I have this tuned right, it turns out that with less than a watt, you can get not only the same effects that you get with a conventional coil, but you can see that they actually exceed what's done with a conventional or a modern Tesla coil. I don't think you can see this really good, but we're about This is about 18 inches away. I'm lighting a full fluorescent bulb, and I'm lighting it with the signal generator. I'm not using a power supply. I'm not using I'm not using an amplifier. I'm not using RF. I'm not using 100 watts or anything. This is simply peak efficiency, peak simplicity. This is one wire fed into one side of this coil that's being amplified and transforming that low voltage, high current into very high voltage, low current. And when I first saw this, demonstrated by, I believe, Eric Dollard, somewhere around 2018 to 2020, this blew my mind because it was so simple that I can't. It was amazing that nobody had done this before. And I think he just did it as a simple experiment and demo. But yeah, I think I can get out to about 2 feet before the bulb extinguishes. And what you'll find that's interesting is that because this coil is so much more efficient, that anything nearby, anything in the room affects the tuning. It's so efficient. If I move my hand, I can detune the coil. I don't even have to touch it. Moving my hand affects the frequency to such a point that I can extinguish it without even coming close. So anybody that works on the bench that has a signal generator, oscilloscope, and is willing to experiment with this, I have some other demonstrations and experiments on my YouTube. They can look at this and try to replicate. But the point is, this is dead simple. It is a signal generator, single coil, no primary, no secondary. And it turns out that such a simple system is actually incredibly complex, incredibly confounding, because there's so many variables that go on that it makes it incredibly difficult to actually predict the factors, the tuning, the impedance matching. This seems so simple, but we've spent 4 years building different variations of this, and we're barely scratched the surface of being able to figure out the peak efficiency and peak design considerations for some of these. So we could go back to the slides when you get a shot. So that's the difference between these two coils. Is the Xtra coil designed with Tesla's principles in mind? We can light bulbs from feet away. If we follow the modern Tesla coil, we can light bulbs at 100 times the power and a 20th of the distance. So this is a very brief rundown. I'll go into more detail when I do a proper presentation. This is sort of a sneak preview. But the main principle for making coils that have an extremely high efficiency is choosing a very low dielectric loss tangent frame material. If you're trying to make coils like this, the proper thing that you want to use is either high density polyethylene or UHMW. They're both polyethylene and have a very low loss tangent. Most people that make modern Tesla coils wind them on either PVC or ABS, which people don't realize is actually about as bad as wood. I have one question. What frequency is the signal gen? This specific coil in the corner was wound for approximately 1 megacycle, about 9, depending on where your hand is, where it is in the room, what kind of ground system you have. It's between about 920 and 1,000 kilocycles. So it's about 1 megahertz coil. One person talking about going back here, the framing material. Yeah, polyethylene was the core key. I can discuss about other framing materials. If you have anything, if you only have PLA and a 3D printer, you can make coils with that will function, that will have relatively high efficiency. But for the ultra peak, anything above a quality factor or a Q factor of about 100, it needs to be basically zero loss material or a coil as large as a building. Moving on here, the wire selection. Generally, you don't want to use, you don't want to go any lower than about 20 gauge wire. Below that point, the resistance tends to be higher than the actual conductance, and it doesn't get a quality factor that you need. A lot of modern coils you will see are wound anywhere between 24 gauge and 34 gauge wire. It's really extremely high resistance. It's almost amazing to get any results with them sometimes. If you want the super duper Porsche style, you can use Teflon coated wire, RG6 RG what is it, 213 RG316 coax is silver coated FEP wire. Feel free to email me or message me on Discord at Hakasays if you have any questions or interested in replicating. Want to go into more details. I also have some other YouTube links where I go briefly into this too, as well as a previous presentation at the ESTC on exactly this topic. Question is, are there math equations available? Yes. The first place that you want to go to is this. A Tesla Xtra coil is a quarter wave resonant antenna. So what you want to do is you can use a quarter wave calculator to start putting the calculating the length of the wire and the general characteristics. And if it's a roughly 1-to-1 coil with some amount of spacing between turns, that will usually get you pretty close, within about 15% of the predicted frequency. Moving on here, if you're trying to do a construction or replication, the technique that I recommend nowadays, I've dubbed it the jigsaw method. What you essentially want to do is you can 3D print machine using a table saw, circle cutting saw, is you make a horizontal rings with certain grooves cut in them, and then vertical risers that fit that. And I'm not sure if you can see that very well, but similar principle that you can see. That should make quite a bit of sense. Jigsaw method using horizontal riser with grooves cut in it, vertical risers with grooves cut in it. You can design this with 3D modeling, perhaps Fusion 360 or Inventor, 3D print prototypes of this using PLA or ABS plastic. It won't have the same characteristics as the coil that you see in the corner here, but it will get you somewhere. Spacing on the risers cut for depends if you're talking about the wire spacing or the distance between the risers. Basically, you want to have enough material that the thing supports its own weight, but minimizing the total amount of material. So the problem is if you make these, if you make the risers, the rings too small, then the whole thing will bend and flex as you wind it. The wire spacing, the per Eric Dollard, the highest efficiency spacing is center to center, about 160% wire spacing. It was 162%. So that would be 62% between wires, or 162% the diameter to the spacing. If that makes any sense. But we found that that's a relatively loose term. You can go quite a bit higher or quite a bit lower without making a big impact. We've already built probably a few dozen of these coils to try to characterize them and understand the different properties, understand the different geometries. One of the reasons was to figure out what framing materials had the biggest impact, whether the geometry, if it was a wide, fat coil, or if it was a tall, thin coil, how that affects the frequency, the dielectric and magnetic components, and things like impedance. We did end up coming up with a Tesla coil calculator that applied some of that. Sorry to go out of order a little bit, but the previous discussion where we're lighting a fluorescent tube at some distance with a single wire signal generator, no primary, no secondary. This is the diagram. It doesn't get much simpler than that. If you have those two parts, you can actually build one. We'll look at some of the details. To tune it, what you actually want to use is an oscilloscope with a wire probe I didn't set it up just because I didn't have space or time. But what you want is an oscilloscope that has a, let's say, 3 or 4 inch piece of wire sticking out of it, and you just leave it anywhere near the room. It doesn't have to be touching the coil or even attached. That actually hurts the tuning. All the coils that I have in the previous slide someone asked is these are all varied from 1 megacycle to about 8. If you go any higher than about 10 megahertz, 10 megacycles, then there's just not enough meat on the coils to have a very good effect. And also, the higher you get in the frequency, the higher the dielectric losses start to compound. Tesla's coils that he had made in the original photos were significantly lower in frequency. That's how he was able to get away with making them out of wood. He was operating at under 100 kilocycles. He was often operating in the 30 to 50 kilocycle range, which isn't, it's low enough to be considered ultrasonic. Yeah, for tuning and testing, it's a simple oscilloscope with a bare wire, and look at some of my other videos if you want more details on that. What can you do with an extra coil and not a full Tesla coil with a primary and secondary? Well, you can do single wire lighting, which I already demonstrated. You can, because of the efficiency, imagine with 5 watts, you could probably light something from 10 feet away. With 100 watts, you could probably light something from 20 feet away. We've done other previous experiments using these we've used these to study and map the monopolar field properties, just trying to analyze a single coil, figure out what's happening between the top and the bottom, the inter-turn interaction, the action between the geometry. This is a lifetime field of research by itself. And as you can see right now, already we're only a half hour in, and I'm skipping so much of this. This is multiple years of effort just on my part, and we've only scratched the surface on this. You can use this as a low-band ham radio antenna, which is part of our work with Eric Dollard and EPD Labs. We've been using a larger version of this type of setup as a telluric communication and telluric test platform. There's essentially, I think I have a later slide for this, so we'll see if we get to that. Can use these coils to measure time of flight, velocity, other predictions like that. There's a potential that the parallel longitudinal frequencies and longitudinal resonance can be used for superluminal or potentially extraluminal communication or power delivery. We don't know. Some of the math provided by Dollard and Steinmetz allows for the possibility, but it's quite an advanced topic that requires a lot more engineering and funding in order to demonstrate. Have we done Schumann resonance power off the ground as your signal generator instead of a machine for power? We have not done that because the coil that would be required for a Schumann resonance antenna would be 7 hertz, and that would be something like 5,000 miles of wire. It would be the size of a skyscraper. It would dwarf what you saw in Wardenclyffe. That's probably why they didn't do Schumann resonance antenna, because the 7 to 50 cycle of range antenna would be massive length of wire. Like an AM radio antenna, exactly. This extra coil is technically identical to an AM radio antenna, except instead of being designed to radiate power off into space, it's made to reflect power and recirculate it inside the system. One of the things we can do with other things we can test is parametric variation. That's variation of inductance and capacitance. That is also another very high level system. That has to do with non-conservation of energy and non-continuity, or continuity but non-conservation of energy. Using complex arrays of circulating currents and changing parameters, you might be able to end up at situations where energy could be produced or destroyed in a system not unlike what you see here. Cosmic induction generator. Anyone that's familiar with Eric Dollard's work knows there's some other experiments using a pair of these coils pointed end to end facing inward. in such a way that the fields that they generate are canceled, or they're not quite canceled because energy can't be destroyed. So they're colliding with each other to create a location of extremely high electromagnetic or magnetodielectric stress that in certain vacuum tubes creates very interesting formations and effects that we've studied and documented bits of. But again, this is one of those topics that's also 5 years worth of work. Like I said originally, Hakasays, I'm more of a MacGyver jack of all trades, so I scratch the surface of everything and hopefully try to deliver a little bit of information to get you guys interested or replicating or things like that. And of course, the last thing we could do with these is you can power this up to a higher amount of power and get really cool sparks. You can use it to make AM modulated musical Tesla coils. You can do all the same classical things you see with the primary and secondary coil. This is one of the Xtra coils, or one of the Tesla coils by Bruce Gavin. This is using a primary on the bottom, an Xtra coil, and a capacitive load on the top. This is a Tesla coil, although as you'll notice, this doesn't look like a Tesla coil that anyone builds today. And yet this is designed to be extremely high efficiency, high frequency. I believe this one is made to pair with our telluric transmission setup, which is right on the edge of the 160 meter ham radio band, which is approximately 2 megahertz or 2 megacycles. Is this comparable to the Alexanderson antenna? The Alexanderson antenna had some similar components, but it was a much more complex array that used layers, and it uses a similar principle, but it has layers and layers of radiators to... I'm not even going to comment. I'm not an expert on that. More complex than this. This was the demonstration that I had done in 2022 when I first showed this in public. That's actually the same coil. It's a little more beat up, but doing the same demonstration in public, I was lighting a compact fluorescent tube, full fluorescent tube. We made it to just about 3 feet before the bulb would extinguish. And I had an oscilloscope on the bottom. You could see the tuning, and we were using approximately 1/3 of a watt. It was between 0.25 and 0.33 watts by what was measured. This is another one of the Xtra coils. This is more of an Alexanderson design. This is built on top of a telluric test platform, but this is also an Xtra coil, just like you see. The very bottom, there's a copper strap that is designed to be as the primary. But you'll notice that it doesn't look like a Tesla coil that people build today. DC or AC, all of these operate on high frequency alternating currents. So high frequency AC, either sine waves or square waves. This is the Eric Dollard EPD Labs telluric test platform. This is also an Xtra coil that's sitting on a deck in the middle of Nevada desert. This Xtra coil is being used as a test platform to try to study current transmission, power transmission into and out of the ground, the same way that Tesla was doing in Colorado Springs and later at Wardenclyffe. Because this is a field that literally nobody has worked on since 1890s, or Wardenclyffe would be what, 1910s. We're not sure what's possible. We're not sure exactly what the capabilities are. But the tests that we have done were very interesting and extremely promising. We know that it's not completely telluric. We know it's not completely operating through the ground. But using this coil, we were operating at approximately 2 megahertz with 160 meter ham radio band. And we were able to get a confirmed quality transmission from Nevada to California. It was approximately 150 miles, and it was intermittent, but we did able to get transmission 150 miles at, what was it? It was less than 4 watts. We had a hard time measuring below 4 watts, so we can say 4 watts was the peak power, approximate power. It may have been as low as 1. So we would have not gotten anywhere near that if we had wound a coil following the modern Tesla coil principles that we see today. Here's a slightly closer up version. You'll notice that this doesn't look anything like a modern Tesla coil. This only has a couple dozen turns. It has very thick copper tubing as the coil. You see that has a top and a bottom ring. And you'll also notice that it has no primary, no secondary. That is the transformer that you're looking at. That's the full Tesla coil. Primary, secondary, everything, all the transformer action is happening in those rings between those turns and between each turn. Someone said, recommend adding some coated ceramic insulators where the frame meets the coils. That is conceivable, but you want to make sure the ceramic has a very low dielectric loss tangent. Here's another one of the Xtra coils, or the Tesla coils that I had presented in 2022. This is two coils that are wound in opposition at an identical frequency, where on the very right-hand side, there's a high-power ham radio amplifier that is essentially pumping power into each coil in such a way that the very center of that field is a giant null field. And when you put vacuum tubes and other things in the middle of that, you start getting very interesting formations. This was actually following some of the work by Philo Farnsworth, trying to create, fusion in a bottle and things like that. But so far, it just makes really, really interesting formations. If you study some of Eric's stuff, he had gotten a lot more interesting effects where you were able to get something that looked like a galaxy formation that would form in free space, floating and circulating inside of a bulb at higher power levels. So that's all I have for Xtra coils. I know it's a really rough primer. I skipped 99% of what is there available. But if anybody has quick questions or comments, if they're curious on replicating, look for Hakasays on YouTube. I did a couple videos explaining some of these basics and doing a little bit more of step by step. If you have an oscilloscope, signal generator, and some time, you can reproduce and build something like this and experiment with it. And I think you'll be very interested and surprised at how complex such a simple system is. So I do, depending on what kind of questions we got, I can also talk about some of the other stuff that that we're doing or that I'm doing that you all might be interested. So give you a second for that. I don't know if there's anything I missed, Steve. If you have any questions or comments, I'm sure I ran through that like blinding fast.
Well, I'm good here.
I got some more slides too. If we run
Okay.
out of if we got more stuff to talk about, but
They still have plenty of time.
okay. Alrighty. Not seeing anything in the chat, so let's see. Was not Tesla's system use Schumann cavity resonance? It's not about using the ground at that case. So the answer for the telluric transmission and Schumann resonance, let's say this one. Tesla was operating at an extremely low frequency, between 30 and 50 kilocycles, which made the wavelength extremely long. More than likely, Tesla, the Schumann cavity was part of that, but we don't know exactly what yet, because the difficulty of reproducing coils that you see here is the coil itself looks kind of complicated, but it's actually pretty simple. The harder part for doing telluric transmission, which is using the earth as an antenna instead of the air, is that instead of needing a very large antenna in the sky, you actually need an extremely intense ground. Like the Eric setup is multiple 20,000 gallon buried fuel tanks, and that's just barely adequate for what we need. What Tesla was using in Colorado Springs was, a massive underground system with irrigation that was running constantly, so the water would would improve the conductivity and make it operate better. In Wardenclyffe, if you look at the diagrams that Tesla had for Wardenclyffe, the the ground system was more impressive than the tower. The ground was built beneath the water tower with large numbers of pipes that were staggered across in every direction like a spiral, or not a spiral, but the spokes, like spokes in a wheel, all pointing out in different directions. And the whole purpose of that was to create not a low conductance, or not a low conduct or high conductivity, but was to essentially create a plate of a capacitor. Because we're not treating the Earth as a ground in the sense that you would conventionally think of it. We're using the Earth as an antenna, and thus you need a very big antenna, which means you need a very big wire connection to the ground. I actually have one of my past experiments was trying to replicate some of that, was using the Earth as a transmitter. I happen to be in a location in Southern California that is very close to the water table, only about 15 feet away. So I did a borehole project where I spent about a few weeks drilling down with a pipe low enough to get to the water table, and I buried a thick steel pipe, iron pipe, about 35 feet down into the water table. What it turned out is that ground system had a ground resistance of less than 1 ohm. I think it was about zero 0.9 ohms, but it had a ground impedance of about 70 ohms. So what happened was, for DC, it had very good conductivity, but for the frequencies that we were operating at, uh, it might as well have been a resistor. And that kind of blew my mind how staggering a difference there between having a plate burying like a tank or barrels, or even operating on actually the best system to operate a telluric, a ground-based Tesla system like that would be on a ship, because a ship would have an extremely high surface area contact to a saltwater ground. So conceivably, the best transmitter receiver systems would actually be large metal hull ships. So it's something worth looking into. But all the team, everybody here, we're all operating on shoestring budgets with limited times, and most of us have day jobs. So all we have enough time to do ourselves is to scratch the surface of this. On that note, have you used a crystal oscillator circuit to drive the coil? No, because a crystal oscillator tends to operate on a fixed frequency, and you could do that, but you would have to tune the coil to the oscillator frequency. And that would often mean either isolating it, tuning it very carefully, and carefully cutting, half-inch or 1-inch wire until you reach the frequency you were desiring. But yes, you could use a crystal oscillator to drive a coil like this with, well, that would be like no power. You'd be talking about microwatts. And you would actually be able to use that as a transmitter, and you could pick up dielectric displacement probably across the room with something like that. So I guess, yeah, telluric test platform. This was the telluric test platform, one of the projects we're working on. You could go full screen on these, talk about some of the other projects we have going on. This was the platform with the design of using a ham radio transmitter and conventional system to transmit power into the Earth and see what properties it had compared to conventional radio, and replicate Tesla's designs as intended to see what we can do with that. We're still right on the scratching the surface phase. We're about to have a beacon station up that was up briefly late last year in August. It was a good experiment and it lasted a few weeks, but still needs that little bit of tweak to get it online 24/7. Sometime in 2026, we will have a permanent beacon station online. This picture that you're seeing, transmitting across space. So any ham radio receiver could tune in to 1999 kilocycle to receive that. At the time of this recording, it's not online, but just keep your eye open. Sometime this year, that will definitely be coming online as a permanent fixture. One of the things that will give us the ability to do is to actually characterize these signals at the 2 megahertz and see what the characteristics are, whether it only works at night, whether it gets better or worse in different solar conditions, or stellar alignments or lunar phases. We don't know yet, so it's one of those things where we just need to start gathering data. One of the possible conclusions we've come to so far is that we might be operating at too high of a frequency and we need to drop a lot lower. We know Tesla was operating at less than 100 kilocycles, that he was down to 50 or even 30 kilocycles. We would love to go that low, but the problem is building a coil like that requires significantly more wire. It needs significantly larger framing, and it also needs special built transmitters. The reason we picked this 2 megacycle mark was because it just happens to be in a perfect low band for that's compatible with common ham radio transmitters. Made it a lot easier for us to get this stuff actually out the door and experimented, rather than add another 5 years asking for donations trying to get something running. Somewhere in the future, we will eventually be getting down into that frequency with high amounts of power, and we'll get there. But depending on how much money we have, donations, and people's free time outside of their day jobs, we'll get to it. And if we don't, hopefully somebody here listening to that might be interested, and there might be in a perfect position with an AM quality ground station, and they want to pick up the pieces and see where we go with that. But you know, all we can do is share what we have so far. This was one of the fun ones when we first started tuning up that telluric platform. He's holding a fluorescent tube just like I was in the demonstration, and he's using it to tune the radio in hand while it's transmitting, because while it's transmitting, it's radiating into space. So it's lighting up the bulb. You can not only tune using the bulb, made it so we could see at night while tuning. It was kind of funny. And I had done another one where I started doing the Star Wars lightsaber twirl at night, so that was fun. So other fun little things you can do with these as show and tell. As long as I'm on the telluric test platform, this was the rough diagram. Tesla Xtra coil on the left hand side, matching transformer, but you'll notice there's no primary, there's no secondary. This isn't a Tesla coil as people would build them today. Another project our teams have been working on is called the EPD Long Lines project. This is part of Eric Dollard's work, which is essentially stringing a few miles of wire often in the Nevada desert, listening to the signals that come off it, and the changes and the pops and squeaks and things, trying to receive the signals to to study what's happening both in the atmosphere and within the Earth. Conceivably to do things like seismic forecasting, which would be which it might be conceivable but not possible. We don't know if it's possible or how well it would work, but we'll say there is a possibility that prior to seismic disturbances and seismic events, there's certain amounts of stresses that are built up within the Earth. Those stresses cause currents to flow within the Earth because of piezoelectricity, stressed rock formations, and just underground currents disruptions that get reflected in the ionosphere and get picked up by systems like this, that we might be able to map them and predict earthquakes somewhere between several hours to several days in advance. The status of this project is we hit a great milestone last year. We actually got a recording station online, transmitting to the internet, and more importantly, recording 24/7. We're still running into issues, but if you look for EPD long lines, or I think I have a link. If you want to write this link down, this is the long lines transmission system. You can do this. This is actually an evolution. It fits with Stephen McGreevy, if anyone wants to look up his work as well. Steve had built a large number of these handheld electrostatic receivers that listen to the ionosphere. And what happens is, if you have these little receivers, the really short whip antenna and headphones, when you listen to the sky, what you end up hearing is hard to describe. It sounds like it's not static. It sounds kind of like popcorn crackles or a crackling fire. It has this very impulsive pop and cracking crackly sound, and it turns out that popping sound is lightning activity globally. And these little handheld, whether it be a little handheld antenna or this multi-mile long antenna field, it picks up these pops and cracks and under and tracks the disruption of them and how they change in character, because these pops and cracks are coming from the Schumann cavity that's being reflected, not only what's happening within the Earth but within the ionosphere. I know I'm really rushing through this, so this is just scratching the surface. You'll get entire 4 hour long discussions from Eric on this if you want the uh, bigger directions and discussions. But if you do want to listen to a sample of this, it may or may not be online at the time of recording. But if it's not online, I have there is a continuous loop that is running if the live signal is offline, that you can get a sample for what does the Earth and what does the sky actually sound like with these types of receivers. This was the work that we had and the milestone we had done last year. This is the data logger system that I had built and installed in the shack. It's pretty cool. It's basically a Raspberry Pi with a sound card that's specifically designed to run on DC and low power, high efficiency. And the bigger issue is not so much the hardware design, but the software. When you're designing a computer that has to run off in a shack that's an 8 hour drive away to troubleshoot and fix, you can't exactly go up there and reboot it every weekend. So we had something that's relatively stable. If you see unsafe link, I'll fix that. That's a expired certificate. Thanks for reminding me. Sorry, I should have got that before the presentation. It's related to the that atmospheric project. I had also done a project last year or the year before that was designed off of Steve McGreevy's principles, which was trying to design a simple handheld receiver that could replicate the same or a similar quality of what we were doing with this long lines project. So if you follow Stephen McGreevy's work, he had these little handheld receivers that are about the size of this, and you plug in a pair of headphones and you hear these same pops and squeaks and crackly sound. That's that whole global ionospheric activity. The problem with these the problem with Steve's system was that it was a very sensitive receiver and very powerful. But the problem was that it listens in a frequency that is the audio spectrum, and it turns out that's very close to power line interference. So the 60 cycle power line noise is basically everywhere. So what made Steve McGreevy's receivers difficult to use is that he made these receivers, but you had to be about a mile from civilization before you could pick them up without the hum. You would listen to it and you'd hear bah from the power line interference, and you didn't hear a whole lot else. The pops and crackles were noise, hard to pick up. So I had personally spent a lot of time reverse engineering the design and experimenting with different filters and principles on it. And I had developed a prototype based on that. I call it the Hakasays Active Attenuation Radio Astronomy Project, HARP 1. And this is essentially an uptuned race car version of Steve McGreevy's setup, which is designed to operate the same as his, except it is active filtration that actually pops out, removes the power line noise. So this can actually be operated in the suburbs or in the city or actually relatively near power lines and things like that. I was intending on selling these, and maybe I'll have some ready by the conference or this year, but so many projects going on right now. There's just a few prototypes I've been working on. I do hope to have them for sale eventually, so more people can listen to this long lines atmospheric reception project. Just it's kind of neat because not only can you listen to the ionosphere and the atmosphere, but you can also use these things as a way to listen to what Eric calls gangrene energy. which is any modern electrical system, puts out huge amounts of electromagnetic interference that can be picked up in the audio spectrum by systems like this. So it's pretty interesting to listen in, kind of like looking at a thermal camera where all of the different it's a world that you aren't normally exposed to. So it's kind of fun to explore that. This was Steve McGreevy's WR3 receiver. I think he has the schematics, and he sells some on eBay, I believe. This was some of the work that I had done making the improved receiver, the Harp 1 receiver, which I do hope to have for sale eventually. Some of the boards and prototypes that I had made. Another one of the projects I'd been working on is I don't even know if you want to keep going, I can keep going. But another one of the projects we were doing was Philo Farnsworth. Sorry. Let me get a sip of water here. 1 second. Sorry. 2023, one of the other things that I had been working on, this was based on the work of John G. Trump. It was called a rotary electrostatic converter. This was also something that Eric had touched on with Chris Carson some years ago, and this was one of the projects I had worked on. It's essentially a spinning variable capacitor. This was John G. Trump. That was Donald Trump's uncle. Turns out he was a big PhD physicist, MIT PhD physicist, and he had worked with Van de Graaff and other names that people might be aware of in the high voltage, high fringe world at the time. So one of the things I had tried to build was essentially a replication of his and Chris Carson's that was basically a spinning variable capacitor. It was a new type of motor or generator that operates without magnets and without coils. It runs purely in the electrostatic domain. Completely different characteristics than you see in a normal DC or coil magnet motor. And it was just so interesting because nobody had replicated John Trump's work since the 1950s. There was some really interesting papers that were written talking about the possibilities, talking about 99% plus efficient power generators and receivers, and then it was forgotten. Industry, the fields, scientific academia had just kind of forgotten it and left it to rot. So it was only Chris Carson in the 1990s would be one of the first people that had replicated this. If you want to look up some of the other earlier details, my attempt was trying to build a higher power version of this. It turns out the Trump motor or these rotary electrostatic converters. The only problem with them, you don't need magnets and you don't need coils, but you do need to run them in a vacuum, and you need to run them in a relatively deep vacuum. So I presented on this in the presentation in 2023 called Slaying Maxwell's Demon, where I showed a couple of these motors spinning up. Unfortunately, like any experiment, it did spin around. It didn't really make any power, but it was there as much to demonstrate the principle as the practicality. It turns out I had not gotten a deep enough vacuum. There were just too many leaks in the design and the system that I had made. And not a failure, but a learning experience. I learned a lot about engineering and design and making the plates, and we did some good proof of principles and learned a lot in the process. One of the things I've been working on the last 6 months or so is designing a deep vacuum chamber system to reproduce this in a proper setting, to reproduce the electrostatic converter in the same setting as Trump. So last few months I've been trying to work on this deep vacuum chamber. As long as you're doing an ultra deep heavy vacuum chamber, you can also do things like the Farnsworth fuser. I have some upcoming experiments with Farnsworth and replicating them in a way that nobody has done. And I don't know if it'll work or not, but it goes on an interesting principle that actually uses something similar to this Xtra coil demonstration, that I think might have some interesting characteristics, or at least might be more efficient. It'll be a fun experiment to try. And there's a whole bunch of other stuff that I could talk about for probably 8 hours apiece, but I think I'm already over an hour here, so I think I'll pass it back to Steve. And if anybody has any other questions, I'll keep trying to hop to get to them. I'll go back on here. Uh, have you tried homopolar generator? Yes, I did try to build a monopolar generator or unipolar, whatever you call it. But I built it so many years ago, my engineering skills were not quite up to snuff. It turned out the problem with the monopolar generator is the brushes and the high speed, and my skills were not up to the point of using a big lathe to get that to run properly. It's one of those things that I do want to get to in the future, because those types of generators are really interesting by themselves.
Well, thank you for that. I say, I do have a comment. Like you were talking about these
I know I was a jackrabbit. I just
that
bounced every other topic.
that Tesla supposedly had back in 1899. I know I'm like Toby. I don't recall anything about any water system underneath the Colorado Springs site. And
I remember he talking about he had to use irrigation to maintain a good ground connectivity in the Colorado Springs. I don't remember the details.
The problem is the only water that was available in Colorado Springs would have been the water pipe for Colorado Springs, and he made a note in the Colorado Springs notes about exactly how far it was from his coil to that water pipe,
water system.
And to build a good ground, he had to dig a hole, a huge hole at the site, and buried a whole bunch of copper plates.
Okay, that makes sense.
The ground. And so water, though, would be at the Long Island site.
Okay, I might have got them mixed up.
Yeah, well, that's just.
But the theme was the same, is that Tesla was trying to get a very, very, very good ground.
Yeah,
Colorado Springs was kind of hard.
All important for that, and grounding is extremely important. In fact, he talks about it. He's talking about Marconi's transmitter and everything. How Marconi was bragging about it. I said, he was the one who told him to ground it, because most of the wave traveled through the thing. So, and I'd like to make a note here too, like Toby Gross. You see his name keep popping up here. Toby actually worked with Robert Golka up at the up in Leadville there at the Climax mine, and he had like the 51-foot coil I mentioned before. Toby actually worked on that. So
right, interesting.
Yeah.
You mentioned Bill. What was it? Bill Weisnack.
Bill
Weissack. Bill Weissack.
Yeah, Bill Weissack.
Yeah, Bill and I hadn't heard of that name, but I looked at some of the pictures that you showed me, and some of the pictures from Bill. Turns out, if you look at the coils that he had, they looked more like the coils that we have here. They were open frame. They had wooden frame supports, and they had a spacing between each turn. So I think that might be one of the reasons his coils worked so well.
Well, Bill was an expert Tesla coil builder. I mean, he was the king,
I can see that. I was just from looking that 10 minutes of research, I could see he knew what he was doing. Got some.
And he built this coil. He built this coil.
Results speak for themselves.
Well, he built this coil that this painter uses to paint for his paintings, like in deep space and that. And the theory is that because he's using the spark that's coming off the coils and that could very well be a real map, so to speak. Man, I can't remember that guy's name of the one he built, and I just had on my tongue. And this guy Chris Carson.
Yeah,
I believe I met him when I visited Borderland Sciences, and when they were located in
the 90s. Wow, you actually might have talked to him then, huh?
Oh, I believe because I went to Borderland Sciences, and I believe him and Peter Lindemann and Tom Brown and Eric Dollar, and then we went to visit Chris, and Chris had the capacitor thing there going. So
he had the motor spinning and everything?
Not the motor. At that time, it was one of the devices where they were it was a capacitive device where they were going to increase the voltage through capacitance, and the high generator that Toby mentions. So yeah,
Interesting.
so
Small world.
it's a small world, and that's a comment. I hope everyone comes to the conference because I think I'm going to have a great time, and you're going to meet a lot of people. I mean, I've been doing this since 1984, and anyway, we have a guest in the things. There's Bernie. Hi, Bernie.
Hello,
Do you have any
pleasure.
questions for Hakasays?
Absolutely
Crypto alchemist.
amazing presentation.
Well, thank
I'm
you, sir.
very, very impressed with your work. And you said you're located in Southern California,
That
and
I am.
just so happens I'm catching a flight there in 3 days' time, and I will be down for 2 months working with Nathan with Old Man Builds. Not sure if you're aware of his work, but does a lot of Tesla coil stuff. And if you're
I
up
didn't know
for
he
it,
was down there.
yeah, yeah. So that's who I'm staying with, and we'd love to meet up with you and possibly do collaboration and do interview and joint
Oh,
experiment
that'll
if you're up
if
for
you're
it.
especially if you're there for a while. Yeah, my
Yeah,
day job is
2 months.
like hit and miss. It's feast and famine, but I'm sure I'll be able to find some time to work with you
Yeah,
guys. It'll be
exactly.
fun
So
to meet
it's
up
like,
in person.
yeah, so I'll get a hold of you there, and then we'll schedule because yeah, I'll be down there for 8 full weeks, so I'm sure we can find one evening or something like that.
Plenty of time. Yeah, I might even be able to work
Perfect.
something out with Griffin if we're in the right location.
Amazing.
I
And
don't know if
then
you've worked with seen any of Griffin Brock's work,
it sounds
but
familiar. I
he's
think Nathan is. Does he have
quite
the really
young.
big?
I think
Does he
he's
have the
only
really
about.
big Tesla coils, like the really big ones, or is that
Oh,
someone?
you're thinking Edmund Parkinson.
No, no,
No,
no,
Griff.
no.
He has
I
some
know.
pretty big ones.
Yeah, I know
Griffin's biggest
Edmund
one was
Parkinson, but no. Oh, sorry. Continue.
no. Griffin's biggest one was he replicated the Tesla shadow graph bulbs, the
Oh,
non
ooh,
the non X-ray X-ray
ooh.
tubes, the
Oh,
penetrating tubes that do not appear to create harmful radiation.
that's
Uh,
even more relevant to my own plasma fusion work that
ooh,
100% would love. And no, I'm working in contact with getting Edmund Parkinson to apply to present at Tesla Tech as well. But it
oh, that'd be
was
cool.
a different individual Nathan knows that's also in Southern Cal that has really huge, huge Tesla coils that like zap up into the sky or something like. So there's
Like
lots of stuff.
grid sized coils. Yeah.
Yeah, 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 exactly. And
Oh,
then
that'd be cool.
also while I'm down there, we're planning on going up and taking a few days to go visit Steve there and help Steve get more situated at his place and do everything we can because this is a full team effort and I love everyone's work. It's just amazing.
That's awesome, and especially the conference. It's a long ways away, so we got a lot of time to get some interesting discoveries and things to present. I don't have an exact list of what I'm gonna bring and what we're gonna be doing, but it's gonna be good at any rate.
Exactly, right? It's like, oh, I know. It's gonna be a amazing first 2 quarters of 2026 before the beginning of the third quarter, where everybody needs to be in Albuquerque, New Mexico, mid-August for Tesla Tech 2026.
And that should be August 12th to 16th. And just check out the website, teslatech.info. But I'm going to have to call that a night, guys. But thank you
Absolute
for showing
pleasure.
up. And
Thank you so much.
thank you for your presentation, Axes. And thank you for Bernie. And thank
Yeah,
everyone in the audience who had all these great comments in that. You know, and
be better if I had about 14 hours to talk about everything I did in detail, but
Well,
oh,
another
well,
thing I could say is we'd love to also have you on the League of Extraordinary Inventors multi-stream we do every Friday night, anytime you have time too, if you
get
want
with
to
me off
share
the
more.
chat. We'll try to
Yep,
coordinate something. We'll
for
see what you
sure.
guys are interested in.
All right,
Yeah.
I'll let you guys finish. Thank you so much. God bless.
see you all next week, and thank you for being such good guests. And
Well, thank you.
y'all have a
It was a
great day.
pleasure, Steve. I love that. It's
All
great
right,
chatting with
thank
you.
you. And we'll talk to you guys later next week.